So you're here to talk about Swift Object Storage and Google Cloud Storage and the migration from point A to point B? Well, you're at the right spot because that's exactly what I'll be occupying myself with today. And hi, if we're just meeting, I'm Michael from Pixeesoft and welcome to the channel. This is our developer show where we define tasks that we have to do and we talk about the obstacles and the challenges and ultimately the lessons learned so that you can learn from my mistakes so that you don't have to make them. So welcome. In fact, are you in the middle of migrating from bare metal to cloud? If yes, then I'm doing exactly the same thing. And if not, and maybe in the future you will be doing this, subscribe if you don't want to miss the next video in this entire series of migration. Well, anyway, so what lies ahead? I mentioned Swift Object Storage, not to be confused with the Swift programming language. That is not what we're going to talk about. We're going to talk about Swift Object Storage from the OpenStack suite. Now, we have an existing application that saves a lot of data into the object storage, and we're trying to migrate this whole application into the cloud. And frankly, everything so far has been a challenge for sure, but everything has been within the boundaries of what used to be really hard, now got slightly easier, and I could solve it myself. But with the Swift Object Storage, I have reached a point where by myself, I don't see that I will be capable of doing it. So let's just jump first into our Scrum board and talk about what's been going on. So right here, you see our Scrum board, and on our last sprint, we talked about OpenCV and deploying what we call the resizing server. That is a server that receives data, uses OpenCV to resize it and sends it back to the client. Meaning there is an edge device, sends data in specific format, then the feeder is where the client is connected and wants to see real-time data and says, hey, but I want it in these dimensions. And OpenCV takes it, the resizing server takes it, resizes it, and sends it back. The challenge we had was that back in the day, a couple of years ago, OpenCV had to be compiled. You had to compile it yourself. And the output of this compilation was a Python bridge. And this Python bridge you would import in your code, import CV2, and presumably it will work. But now you can just install through pip a dependency, OpenCV, that already has the library statically binded, and it has the bridge, and it should work. Well, I'm happy to say that not only it should work, but it actually works. And it's deployed, and it was a painless deployment, and I have to say that the very, what was it, not the first, but the very first major minor. So let's say that they had the first release and then they had 3 minor fixes. So the third fix before they had a major release in like months ahead. The first major release works like charm. Exactly the way OpenCV worked a couple of years ago when you had to compile it yourself. So that was painless. Great, done and done. But moving on, Swift Object Storage. So Swift Object Storage can be installed in 2 ways. For your dev mode, you can have it. I have it right here. You can have the Swift all-in-one, which basically deploys all of the necessary services running within OpenStack. That's authentication, that's authorization, that's roles, that's bindings, and all various things. And somewhere low at the pecking order is also the storage itself. However, the Swift all-in-one is, let's say, a quicker version to deploy it for your development purposes, right? And so in my head, I thought, okay, so it's a dev environment. it should be fairly quick, right? In fact, this tutorial is very lengthy and takes a lot of time, and it is a lot of sysadmin operations. Now, there's nothing wrong with that. However, with great power comes, well, you know it, great responsibility. And if I were to deploy this like that, I have to literally take care of it as a sysadmin. I have to maintain it, I have to update it, I have to make sure that everything is running. And it's not like a solution where I would simply click deploy and it would be a managed solution, or let's say it would be half managed, that it would be a package or a Docker container that I would just spin up and cross my fingers that nothing goes wrong. And unfortunately with this is a lot of work to maintain. And this is just the beginning. That's only a development Swift. That is not a production Swift. The production Swift has certain other bells and whistles, and you need to take even more care with it. And you probably want to have it horizontally scalable, you want to have multiple shards, you want to just make sure that it's running. That particularly actually is not a full-time job, but it is a lot of work, and there should be a person dedicated just for that. So for this reason, where I need to migrate an existing application without spending too much time on pretty much doing what we've already done on bare metal with the help of a team of sysadmins, what I need to do is I probably just admit that the way to go is to use an off-the-shelf provided product from a cloud provider. And since we're using GCP, we will be migrating to Google Cloud Storage. Now, Google Cloud Storage isn't as neat as S3 with regards to its relationship to OpenStack Swift. The reason being that it's slightly different. Now, I'm not saying that it's completely different, because in fact, the underlying philosophy of accessing the data is very similar. However, there are some differences with regards to the SDK. You can't just take Swift SDK and only change the URL and maybe the name and the password and add one field and that's it. It works slightly differently. The authentication specifically is different. The Swift OpenStack authentication has either temp auth, that would be the development server. That's pretty much you send credentials and you get back some token. Or then you have Keystone, which is slightly more, let's say, secure or robust or sophisticated, if you will. Now, Google Cloud Storage uses the standard OAuth. It has their own JSON files that you have to have in your code that you use, and you then need to configure the access from within your service into the Google Cloud Storage. You have to sort out the IAM, but you already have an interface for it. And you can probably even write a Terraform recipe for it. So I think that the time that I spend on rewriting the API, because it's nicely written, it's a layered application, and there is a class called Swift Access, and you basically just rewrite the client. Just take the client that downloads, uploads, and that checks. And that's pretty much it. The script is in fact 500 lines of code, Python code, 2.7 Python code, but not to worry. There is a dependency for Python 2.7 still. It's not 2020 yet, so it's there. And you basically just reinstall the dependency, and then I'll have to go through the code. Now, I already thought about yesterday when I was done with the OpenCV, I already gave a thought to the difference spent on the Swift and how much time it will take me to not only install it, but install it for production and then maintain it versus taking those 500 lines of code for Swift and rewriting it into Google Cloud Storage. Now, there is of course something to be said about introducing bugs. Sure, yes, I will probably introduce some bugs and it will probably take some time. But once it's written, I don't have to maintain the Google Cloud Storage. Now, for some naysayers, of course, this is a major vendor lock-in. But since it's just one class, might as well take that Swift client, make a copy of it, then rewrite the copy so that it maintains the same interface. And should we want to switch later on, I just interchange the classes again. So I think that there are ways of making this the right way, and there are ways of making it the wrong way. However, also, the Swift client uses the V2 keystone authentication, which has been deprecated since the version Pike. Now, it hasn't been deprecated since Pike, it has been removed since Pike. It was deprecated before that, but Pike removed it. So if you install everything after Pike, right now, the newest version I think is Stein, and Stein doesn't have it. So even that access is now broken. So there will be changes, no matter what. But this time, I think I will go for the rewrite of the Google Cloud Storage. So taking it back to the Scrum board, right here we have in progress deploy Swift Object Storage service, size medium. Now that is grossly underestimated. I'm going to change it to large just for history records, and I'm gonna put it in the freeze box because I am not going to do that. And I will add a card, right? Client for Google Cloud Storage for object saving. And I'm going to say that it will take me the whole day. And it's definitely def. And that's what I'm going to be doing today. Now, there are snippets. Pip install, great. That's a great start. And then there are snippets how to do that. So I'm going to be comparing Swift to Google Cloud Storage, the various access points and the various ways how to connect it. And I'll try to rewrite the parts that are crucial to the application. Now, there's this one thing that has to be working in order for the storage to be good enough for our application. And that is accessing the objects with an offset. So we have a lot of real-time data. There is loads of real-time data coming in big volumes in a very short span of time. And Swift was not happy if you inserted data multiple times per second. It just didn't know what to do with it. So what we opted to do instead is take one edge device that sends multiple data in 1 second. We take it, we cache it, and then once every certain amount of time that Swift finds comfortable enough, we take it, put it into one big block or blob, and save it into the object storage. If you then want to access it, for that we have indices in the MongoDB server. And there, if you need to access a specific portion of the data, you call the object storage and you set the offset and set the length that you want. And you retrieve that back and send that to the client. And that works just fine. And thank goodness that Google Cloud Storage has that function. It doesn't have one function that might not be a problem. Now, because of the definition of how checksums work, Google Cloud Storage is unable to send you a checksum for a partial piece of data. Let's say you say on index 4, I want you to send me 16 bytes. And it does that, but it doesn't send you the checksum for it because it would have to fetch it, compute the checksum. I presume that it's not computationally efficient to do, so that's the reason why they're not offering it. But let's just hope it won't be a problem. We'll see. I'll have to tackle that and I'll definitely tell you tomorrow. Okay, so I think that's enough for the intro to it, or let's say the problem that lies ahead and its introduction. And as I say, I always want to try to keep it short, brief, and to the point, but I felt like today was a stand-up where I had a lot to share, and hopefully you got some value from it. And if you did, can you please hit the like button and subscribe if you want to keep this conversation going. But this is it. I will just add that we write everything about everything we do and all the lessons learned on our blog, which is pixeesoft.blog, and you can check it out. Follow us on any other social media other than YouTube, which is Instagram, Facebook, Twitter, whatever works for you. And that's it from me. Thank you for watching. Comment below if you have any findings with Google Cloud Storage. I'd love to hear it. Or tweet it at us. And I'll see you tomorrow on our next daily Scrum.